This is lesson 3.5. We're going to learn about exponents, but this time we're going to learn about 0, an exponent of 0, or an exponent that is a negative number. And I'm going to try to just develop the concept with you through patterns. So if we start at the top here with number 27, what happens to get from 27 down to 9? Divide by what?
3.
Divide by 3. What happens to get from 9 to 3? Divide by 3. What about from 3 to 1? And here we can keep on going. See, this is going to be the part where we want to realize that the pattern just keeps going. 1 divided by 3 is 1/3. 1/3 divided by 3 again is 1/9. And 1/9 divided by 3 is 1/27. So that pattern continues. Do you believe me? Yeah? Good. Carry on. So let's look at our next column. I can express 27 as 3 to the power of 3, which I've written over here in my third column, 3 times 3 times 3. I can represent 9 as 3 squared, and I can represent 3 as 3 to the power of 1, just one factor of 3. And if I fill in my last column, you start to see another pattern. If we follow this pattern down, what should be my next power in this column?
0.
3 to the power of 0. 3 to the power of 0 is 1. Okay? Now, over here, we've said we're dividing by 3 each time. So really, what we have here, I'm going to erase this, but we have 3 over 3, right? Because we had 3. Let's start at the top. If we have 3 factors of 3 and we divide it by 3, basically we're just crossing out a factor of 3, leaving us with 2 factors of 3. Divide by 3, 1 factor of 3. Divide by 3, we get 3 over 3, which is 1. Okay? Any number to the power of 0 is going to be that number over itself, which is 1. We're going to write that rule in a second. But let's follow this pattern a step further. What should my next power be? 3 to the power of?
-1.
3 to the power of -1. 3 to the power of -2. 3 to the power of -3. And in our last column, we're going to take a look at what that expands out to be. So if we have 1, and we're going to divide it by 3, then we have 1 over 3. 1 factor of 3. And look at this, actually, is 1 over 3 to the power of 1. So we started with 3 to the power of -1. And that's the same as 1 over 3 to the power of +1. Well, if we divide that by 3 again, really all we're doing is putting another 3 in our denominator. So we end up with 2 factors of 3 in our denominator. Well, isn't that the same as 1 over 3 squared? And that matches up with our first column, 1 over 9. How could we express 1 over 27 using factors of 3 in the denominator? Well, 27 has 3 factors of 3. So hopefully you can start to see the relationship between this, I'm going to use a different color here, between my power with a negative exponent being expressed as a power with a positive exponent, and you can see how this 27 had 3 factors of 3 in the numerator, and this 1 over 27 has the same thing, 3 factors of 3, but this time in the denominator. So we can express negative powers, powers with a negative exponent, as powers with a positive exponent by putting them, flipping it, put it 1 over the power. Okay, we're going to write those rules. Hopefully you have some space off to, do you have some space off to the right? We'll put our rules there, and then we'll do a couple of examples underneath. So 2 rules. X to the power of 0 equals 1. this is true where x is any number except 0. Wouldn't make sense to do 0 to the power of something. But that's your first rule. X to the power of 0 equals 1. That means 7 to the power of 0 equals 1. Negative 10 million to the power of 0 equals 1. 364.789 to the power of 0 equals 1. Anything to the power of 0 is 1. The next rule we have deals with a negative exponent. So we have any base x raised to any negative exponent is equal to 1 over that same base with a positive, with the opposite exponent. And this is true where x is any number except 0. Okay, let's try a few examples. Example 1, these ones will be pretty straightforward. We're just applying our rules. Yeah, you'll have enough space. It's not many examples, 3 examples. Example 1a, 4 to the power of 0. Sanquan, what's 4 to the power of 0? Read your rule. 1. Okay? 1. 4 to the power of 0 equals 1. Anything to the power of 0 equals 1. B. Negative 5 to the power of 0. Karis? Read your rule. Anything to the power of 0 is 1. You don't believe me yet. I'll have to show it another way. C. This time, the negative symbol is not in a bracket with the value 2. So here we have 2 to the power of 0, which is
1.
but then we have negative that.
So it's negative 1.
So it's negative 1. Okay, because you don't believe me yet,
I believe you.
we're going to do this rule.
I believe him. I didn't say it.
Let's say you have 2 to the power of 3 divided by 2 to the power of 1. Which exponent rule is this? It's the quotient law of exponents. What do we do to our exponents in this situation? We subtract them. Okay? So first I'll show it in expanded form. It's 2 times 2 times 2 divided by 2 to the power of 1, which means we just cancel out 1 and 1, and we're left with 2 to the power of 2, which is 3 minus 1. Keep paying attention. What if we have 2 to the power of 3 divided by 2 to the power of 3? We know it's going to be 1, but watch what happens in expanded form. We've got 2 times 2 times 2. And in the denominator, we also have 2 times 2 times 2. So these guys cancel out to become factors of 1. They don't just disappear into thin air. They become 1 over 1, which is just 1. These guys cancel out. They're 1. These guys cancel out because 2 over 2 is 1. Well, look at what happened. If we write it using our quotient law, we've got 2 to the power of 3 minus 3, which is 2 to the power of 0. And we just figured out that that's the same as 1 over 1. Anything to the power of 0 equals 1 because all of the factors in the numerator and the denominator will cancel out. That's the key to why this is actually true. And then if we got into negative exponents, which we're not going to do right now, but basically this is saying, okay, well now there's only 2 factors in the numerator, but there's 3 factors in the denominator. So when we cancel out, we actually end up with 1 factor left over in the denominator, which gives us 1 over 2 to the power of 1. And according to our quotient rule, we would have 2 to the power of 2 minus 3, which would be 2 to the power of negative 1. So that's another way of showing that 2 to the power of negative 1 is the exact same as 1 over 2 to the power of 1. Okay, because there's a factor left over in the denominator. Okay, example 2 is just evaluating, and this time we're working with powers with a negative exponent. So example A is 4 to the power of negative 3. Now according to our rule, I can rewrite that. Here I have 3 factors of 4, but they are in the denominator. So I can rewrite this as 1 over 4 to the power of 3 with a positive exponent, which is the same as 3 factors of 4 in the denominator. And I can evaluate that. 4 times 4 is 16, times 4 is 64. So basically, if we know that 4 to the power of 3 is 64, then we also know that 4 to the power of negative 3 is 1 over 64. Let's try another one, and this time we're going to have a negative base. The rule stays the same. We don't need to do anything differently. We don't need to change the rules. All we need to do is express this as a fraction with a positive exponent. So we know that we're going to be 1 over our base, which is negative 3. I'm going to keep it in brackets. I don't want to change anything. But now I can use the opposite exponent. So instead of negative 3, we have positive 3. And to evaluate that, I'm just using my same laws. We have negative 3 times itself 3 times. So 3 cubed is 27. And I have 3 negative factors.
And 1 is always going to be on the top.
1 is always in the top. That's the rule. So we have negative 27 in the denominator. That's never good enough for a final answer. For your final answer, you're not going to have a negative in the denominator. Instead, we'll put that negative symbol right out front. So we have the fraction negative 1/27. If you have space to the right to do one more example, go for it there. I am going to just jump down to make some more space for myself. But here we have an expression with 2 powers. We have 2 to the power of 0 minus 2 to the power of negative 2. So we're going to deal with these things separately because they're separated by a negative symbol. But what is 2 to the power of 0? Anything to the power of 0 is 1. So what's 2 to the power of 0? 1. Now we have a minus, and then we have 2 to the power of negative 2. Well, I can express that as 1 over 2 to the power of positive 2. Now I can simplify my pieces. I've got 1 minus, and 1, what's 2 to the power of 2? 4, so that's just 1 over 4. So I have 1 whole minus 1 quarter. If you have a whole pie and you eat a quarter of it, how much do you have left? 3 quarters. Okay? Take your time, step by step, apply the rules. There's really nothing tricky about it if you use the rule carefully and properly. Your 3/4 is 1 quarter, or sorry, 3 quarters. This. Okay, example 3 gives us basically just harder examples to try. The first expression that we're going to evaluate is 3 to the power of negative 3 times 3 to the power of 5 times 3 to the power of negative 4. Now there are a couple of different things happening here. You notice that we have powers with the same base, 3, 3, 3. We also have 2 negative exponents. So you might be inclined to flip those and express those as positive exponents in the denominator. But we have another rule that we can do first to take precedence and make this a little bit easier. We notice that we have powers with the same base, and they are all multiplied together. So we actually have the product rule of exponents, which says that if you have powers with the same base multiplied together, all you need to do is keep the base and add or subtract the exponents. So we're going to add all these exponents. We've got, sorry, not add or subtract, just add the exponents. We have an exponent of -3. We have an exponent of +5. And we have another exponent of -4. So in the exponent, we simply have -3 plus 5 minus 4. Well, -3 plus 5 is 2. Minus 4 is -2. Now I have a single power with a negative exponent, which I can express as a positive exponent because 3 to the power of -2 is the same as 1 over 3 to the power of +2, and we know 3 to the power of +2 is 9. So this thing reduces to 1/9, 1 over 9. Again, we applied the product rule of exponents, then the rule for negative exponents. B, -2 to the power of -5 divided by -2 to the power of -2. Same situation here. You might be inclined to flip both of these. That's not the fastest way to do it. We're going to first apply the quotient law of exponents, which says that if I have powers with the same base, which I do, -2, and they're divided by each other, I can simply subtract the exponents. So watch and be very careful because I have an exponent of -5, and then I'm actually going to subtract an exponent of -2. Well, when we subtract a negative, we're really adding. So I actually have -5 plus 2 in the exponent, which simplifies to an exponent of -3. Now, because I have a negative exponent, I can express it as the reciprocal with a positive exponent. So we have 1 over -2 to the power of 3. And -2 to the power of 3 is -2 times itself 3 times. Well, 2 to the power of 3 is 8. And we have 3 negative factors, an odd number of negative factors. So we're going to have 1 over -8. And again, we wouldn't keep our negative sign in the denominator. We would rewrite this as -1/8. There are 2 more examples here. C is 4 to the power of -1 to the power of 2. Which law do we have at work here? So this one is called the power law of powers. Power of powers. So we have a power, 4 to the power of -1, raised to another exponent. So we have a power of a power. Well, the power law of exponents says if you have a power raised to another power, you can just take that base and you can multiply the exponents. So we have -1 times 2 in the exponent. -1 times 2 is -2, and we can express that power with a negative exponent as a power with a positive exponent. 1 over 4 squared, which is 1 over 16.
We have to draw up
All right, example D. This one gives us a situation where we have a negative exponent in the denominator. The same rule applies. You can simply take the reciprocal of this situation with the positive exponent. So we can rewrite this, instead of 5 to the power of -2 in the denominator, we can write it as 5 to the power of +2 in the numerator. And if I make that very clear, it looks like that. Yeah? All we did is flip it and then use a positive exponent. Well, 5 to the power of 2 over 1 is the same as just 5 to the power of 2. And 5 squared, 5 times 5 is 25. All right, 3/4. Your practice problems are on page 112. We can do number 1 through 79, and then 81 through 83. Enjoy.